Hello friends, today I will discuss the PMMC instrument. The full form of PMMC is nothing but Permanent Magnet Moving Coil Instrument. So here I will discuss the necessity, definition of the meter, principle of the instrument, construction of the instrument, advantages, disadvantages and applications of the instrument. First point is necessity. This instrument is necessary to measure parameters, DC parameters like current, voltage. Next, definition. It is a device used to measure only DC parameters. That's why it is called MC meter or PMMC instrument. Next, principle. This follows motor principle, that is Fleming's left hand rule. When there is a current carrying conductor placed in a magnetic field, then the conductor experiences a mechanical force to rotate. Similarly, here also, the current carrying coil is placed in the uniform permanent magnetic field, then the coil experiences angular rotation to show the deflection on angular dial. So here the moment of the spindle or the moment of the coil is restricted due to the presence of control torque and damping torque. Next, construction. The construction of the permanent magnet moving coil instrument can be explained by 5 points, that is moving coil, magnet system, control spring, damping, pointer and scale. So here moving coil means it is a moving conductor. So magnet system means it's a permanent magnet system. Control spring means that will provide the control torque. Damping means it provides the damping torque. And pointer and scale means scale is designed to measure certain parameter and pointer will move over the scale. So let us see what is the diagram of the permanent magnet moving coil instrument. So here this is a U-shaped permanent magnet, and here there is a soft iron piece. Over that there is a rectangular former, and on the former a coil is wound like this, and there is a spindle going through this former and through the soft iron like this. This spindle carries two springs, each spring wound in opposite directions, and the spindle also carries a pointer which moves over the scale. In this case, the parameter, the current to be measured will enter this point of the spring, that is lower control spring, and leaves the upper control spring. Means this springs will provide the path for passing current through the coil. This diagram can also be drawn like this. Though this is the permanent U-shaped magnet, and this is the north pole, and this is the south pole, and this is the soft iron core. And the soft iron core is placed to reduce the reluctance in the magnetic field, and here is the spring which provides the path for current through the coil, and this is the pointer, and the pointer moves over the scale, that is from 0 to 10 like this, and this is because here it is shown as amperes, means this is ammeter. And similarly this also can be drawn like this. So this is the soft iron and this is the former, and over the former there is a coil wound over it, and this is the spring, here also spring, and this is the spindle, and here is the pointer connected to the spindle. This PMMC instrument is also called the de-Arsenoval galvanometer. If we connect a high resistance in series with the coil, then it works like a voltmeter. If there is a shunt resistance connected across this coil, then it works like a ammeter. When this is used as a voltmeter, the former should be metal former so that it provides the damping torque. Whereas when it is used as a ammeter, the former should be non-metallic former so that the coil itself provides damping torque. When current flows through this coil via these springs and it is under the influence of the permanent magnetic field, so this coil which is on the former will experience the mechanical force so that it moves from left to the right like this over the scale, angular scale. That scale may be 180 degrees or 90 degrees or 270 degrees. The advantages of PMMC instrument is that its scale is very uniform throughout the dial, and it has very high torque to weight ratio, and it consumes very less power, and it also shows high accuracy because it is used in DC system. So the frequency is 0, so automatically hysteresis loss also 0, and it has efficient damping characteristics so that it will not be affected by stray magnetic field. And with this instrument it is possible to use as ammeter by using shunt and as voltmeter by using series resistance with the coil. Since here the coil moves in the permanent magnetic field, so it is called the permanent magnet moving coil instrument. Coming to the disadvantages, it has comparatively high cost. It is only suitable for DC measurements. Aging of permanent magnets and control springs introduces errors in the measurement in the long run. Coming to the applications, it is used to detect small currents in DC galvanometers like in Wheatstone bridge. It is used as ammeter. It can also be used as voltmeter. It can also be used as ohm meter. It can also be used as galvanometer. It can also be used to measure the change in magnetic flux linking with the galvanometer. So practical voltmeter can be seen like this. So look at this. This is the voltmeter whose maximum voltage is 15 volts, and here is 0 and here is 5, here is 10 and here is 15. So the space between the 0 and 5 and space between 5 and 10, 10 to 15 is same. That's why we can say it has the uniform scale. So this can also be verified using the torque equation for the PMMC instrument. So suppose we assume the number of turns on the former is N and B is the flux density, then L is the length of the coil, then D is the width of the coil, and I is the current flowing in the coil, then we can write as G into I, where G is nothing but NBLD. Then we know the control torque is provided by the spring, and spring constant, let us say K, Then control torque can be written as Tc is equal to k theta, and where theta is the angular moment of the coil. At steady state condition, deflecting torque and the controlling torque are same, means are equal. So deflecting torque can be written as Td is equal to Tc, and we have written here Td is equal to Gi, and Tc means control torque is written as k theta. So from this, the angular deflection of the coil or angular moment of the coil can be written as theta is equal to G by K into I. So this clearly shows that theta is directly proportional to the current because G and K are constants. So the scale of the PMMC instrument is linear. Let me summarize once again. The necessity of the permanent magnet moving coil instrument is that it is necessary to measure the DC parameters, and definition means it is a device used to measure only DC parameters. Coming to the principle, it follows the principle of the motor. Only thing is its rotation, the spindle rotation is restricted by the control torque, and damping torque is provided to suppress the oscillation of the pointer on the scale. And construction is nothing but it consists of the magnetic field, magnetic system, a coil, and the pair of springs, a pointer, a spindle, and the deflecting scale, deflection scale. So since here the coil moves in the permanent magnetic field, so it is called the permanent magnet moving coil instrument. And we have seen what are the advantages and what are the disadvantages and what are the application of the instrument.